Hello Math 1, I've got a new video for you guys. It's 3.4. We're going to talk about compound inequalities with their special cases. And there's actually quite a bit of them. It requires a lot of logic to think your way through these. So, what are the special cases for compound inequalities? I think the best way to answer that is to say it's everything except the normal cases. So what are the normal cases? So I'm going to answer a question with another question. What are normal cases for compound inequalities? Because sometimes identifying the special ones requires you to really know the normal ones. So if it's an or statement, what are we used to? Well, we're used to, on a number line, maybe one going to the left and one going to the right like this, where there is no shared space. Okay, so ors have traditionally just done this. And statements have traditionally done this. They've gone towards each other, and means what they share. Okay, so what they share would be the space in between them. And again, guys, if you're kind of confused about this, go back and watch the videos for 3.3 and it'll explain everything. So what happens when you get an and statement where they're not going towards each other? What happens when you get an or statement when they're not going away from each other? That's what I intend to tackle on this video. So I'm going to give us a little more room below. There we go. All right, so our first one. X is less than 2 and X is less than 5. So before I even begin this, I'm looking for the shared space between less than 2 and less than 5. So what do they share? So to visualize it, I'm going to graph on a number line 1, 2, 3, 4, 5, 6. And they're open circles. Whoops. I'm going to go open circle at 2, and it's going to the left because it's less than. And on the 5, open circle also going left. All right, so what does that look like? Okay. So the question is, what do they share? What do they share? Well, it's the space that both the red graph and the black graph occupy. Where do both red and black number lines or solution sets exist? Well, you see where they're both double here? This is the spot where they both share. So here's what you do. You say, everything left of 2 is the solution. So, X is less than 2 is the solution set to that. So our final answer is X is less than 2, and then what we do is we make sure everybody understands, and this is what the graph looks like for X is less than 2. So this is sort of like your starter kit. This is the end product. All right, let's try it again with the next one. You've got X is greater than 3 and X is greater than 6. So again, we're asking the question, what do they share? And a good way to do this is to just graph on a number line initially what you see. So I'm just going to go 1, 2, 3, 4, 5, 6. Maybe go left a couple. In black, I'm going to go open circle at 3, and it's going to the right because it's greater than. Open circle at 6 in red, and that's also going to the right. So then you ask yourself, what do these two solution sets share? Well, the overlap seems to be everything in this area. This is what they share, which consequently is everything bigger than 6. So what we say is, just like over here, x is greater than 6 is the solution set. And then the graph for that, I'll just skip count on this one. 2, 4, 6, -2. Open circle at 6, and everything to the right. Sorry, I didn't give you a whole lot of space for that. All right, so I think you guys are getting the gist of this. I'm going to do the same thing here. X is less than -1. And x is greater than 4. What do they share? All right, what do they share? Well, if I graph this, -1, 2, 3, 4, 1, 2, 3, 4. I've got an open circle at -1 going this way. I've got an open circle at 4 going that way. And it's and, so it's definitely asking what do they share. What do they share? Where do the red and black ink overlap? Nowhere. There is nowhere where red and black ink overlap. So here's what I'd say. Since they share nothing, since they share no space on the number line, wait for it, it's no solution. So the no solutions are coming back. There is no solution. So that's our final answer. Our final answer is no solution. And then you would graph that on a number line. Just like these two were the final answers for this one, these two were the final answers for this one. The final answer on this one is just going to be the empty set. Interesting. Okay, now, number 4. I think this is our last and statement, at least for this part of the notes. So x is greater than 2 and x is less than 4. What do they share? Well, let's graph this thing. I've got my number line. I'm going to skip count by 2s. Here, let me make sure you guys can see this all in view. Barely. That's better. All right. In black ink, I'm going to go x is greater than 2. In red ink, I'm going to go x is less than 4. So what's the shared space between the red ink and the black ink? Oh, this is a normal case. Normal and case. Which, if it is a normal and case, what you can do is say, I guess I'm just shading between them. I guess what I could make here is to say that 2 is less than x, which is less than 4, is my solution. Because remember when I show you guys how to make a connected solution at the end? You can do it with any and situation. And then you would graph in between them. So you're going to graph a new number line. Put open circles at 2 and 4. And then shade between them. All right, guys, I think that's a good place to stop this video. It gives you an overview of all the special cases with ands, at least the start of an overview. And yeah, check out the next video for the or statements.